All right, when we first got together to decide which of our previous speaker alumni we wanted to have back to get a sense of what had happened to their story, how had they advanced their projects, I thought about Brad Edwards. He's the guy who proposed a space elevator. And given today that we are 10 years later, and in the area of space exploration, we've seen a massive retreat of governments in the face of the costs of those kinds of programs. And when you realize that an enormous amount of that cost is invested and expended in the sheer act of getting off the ground and carrying all that fuel with you, I thought the space elevator made a lot of sense. And what I remembered of Brad's presentation was that the limiting factor in this idea of a space elevator was the rope, the steel cable, or the cable, which was going to connect a spot tethered on Earth to another spot hanging out there, or down there, held by gravity in order that we could then inch up it in an elevator. And the limiting factor, of course, was 62,000 miles of steel cable, an enormous weight, a practical impossibility. A little later, I heard about carbon nanotubes and that they were an order of magnitude tougher, lighter, and perhaps the beginning of making such a dream possible. And later still, literally in the last few months, I heard about an even more miraculous material called graphene. So that's the context of this session. And we will begin with Elena Polyakova, who is going to tell us about this astonishing material. Enough of it, pounded out to cover an entire football field, is going to weigh less than a gram. It is hundreds of times, I'm told, stronger than steel, stronger than Kevlar, and is an astonishingly good way of transmitting electricity, right? Elena Polyakova. Thank you for
Nice to meet you. So good afternoon, everybody. I am a CEO of Graphene Laboratories, one of the major manufacturers of graphene, and recently we founded a new company, Graphene 3D Labs, and I am Chief Operating Officer of this company. And today I will talk not only about graphene, but also about 3D printing, because our new venture is devoted to 3D printing with graphene materials. So where's my clicker? So today I will try to answer this simple question. How will we make things 50 years from now? So let us take a few steps back. And we definitely know that new materials always open new opportunities. And if you just think about it for a moment, that nature didn't give us too much. What nature gave us is basically our nails and our teeth. That's about it. But we were lucky to find out that we can use our brains and we can develop materials which are not available in nature. So first of all, we figured out how to make first bronze, then iron, and we were able to move from caves to much more comfortable accommodations. After that, we developed many new materials. During the last 2 centuries, we made stainless steel, rubber, you name it. And what is absolutely miraculous, we were able to leave planet Earth and actually made our first steps into the space. And in order to do it, we really had to do a lot of work with materials. And without true material revolution, it wasn't possible to go into space. Later on, we found out how to make materials with atomic precision. And all our electronics is built on single crystal silicon. And in order to make our modern computers, we have to control matter with nanoscale precision. So, and now just look around us. So can you imagine a world around us without computers, without materials that we designed and manufactured ourselves? It's not something that Mother Nature gave us. And now let us think, what will 21st century bring us? And of course, there is a lot of exciting development all around us. But today I will talk about wonder material graphene and a new way to manufacture things, which is called 3D printing. I guess that most of you are familiar with the concept of 3D printing, so let me just briefly go over concepts of 3D printing. So in this case, if you have a computer and you know how to use a CAD program, you can design an object in 3D space. After that, you can transfer this computer file into a 3D printer, and you can wait for a few hours, and after that, a physical object, which represents your computer model, will be built. And I just want to show you a couple of simple examples of what you can do with 3D printing now. First of all, you can make a simple toy, for example, it's just a tree model. So another example, you can make a customized, nice case for your iPhone. And if you want, you can even like print your own name or even your dog's name on it. And this thing is very cool. Let me just explain briefly. So this thing has 7 different pieces. And you cannot make this thing by any other means because you cannot take it apart and just... So it's something that you can do with 3D printing today. Oh, sorry. So what's the difference between our traditional manufacturing and 3D printing? If you just look at this particular picture, for example, we want to make something complex. So right now, what we do, we usually manufacture hundreds of complex parts, and in many cases, we have to transport those parts from different countries, and we burn a lot of natural resources. Also, when we make parts by subtractive manufacturing, we usually create a lot of waste. But if we use a 3D printer, we can just print the whole thing in one 3D print. So now let me briefly introduce you into the world of graphene. So let me start with definition. What is graphene? And graphene is single atom, thick sheet of carbon atoms, and it can be visualized as a hexagonal lattice, as you can see on this image. So why everybody is so excited about graphene? And in this case, I think it was absolutely great introduction. It's absolutely amazing material. So if I speak in, let's say, in scientific terms, it has incredible electrical conductivity. It has incredible thermal conductivity. It's also transparent, flexible, and incredibly strong. And apparently, in scientific community, it's created a lot of uproar. And it has been discovered in 2004, and as early in 2010, the Nobel Prize has been awarded to 2 scientists that discovered graphene. And actually, it's probably the fastest Nobel Prize in the history. And many people agree that graphene is expected to be as revolutionary for our civilization as plastics were in 1950s. So what we can do with this exciting material? Apparently, we are given here only 17 minutes, and there is absolutely no way I can describe it in 17 minutes. So first of all, graphene is flexible, transparent, and conductive. So we can make a touchscreen. So in this case, just imagine what we can do with such material. For example, we can create a watch or cell phone which kind of is wrapped around your hand, or something like this. Also, graphene can be used to create next generation of electronics. And many large companies such as IBM, Nokia, and Samsung are already working. And they have working prototypes of graphene transistors. And IBM demonstrated that graphene outperforms silicon. And another very exciting area is energy storage. Graphene batteries are really, really good. So graphene batteries can hold more charge. So as a result, they will last longer, and they will be lighter than batteries that we are using right now. And what is also very exciting, that graphene batteries can charge not in hours, not in minutes, but in seconds. And the commercial potential of graphene is recognized not only by scientists, but also of governments worldwide. For example, European Union invested more than $1 billion euros in graphene research. It's really unprecedented amount of money if you just think about it. And also Korean government invested a lot of money. And I don't know how many commercial projects, graphene related, we have around the globe, but from R&D perspective, it's absolutely amazing. And I expect to see a lot more new discoveries. Also, graphene can be added to polymer materials. And in this case, you can add just a little bit of this material, and you can make polymers lighter, stronger. And apparently, those new composites can be used to make next generation of cars or airplanes. So now let me discuss. So that's a new topic. So we're trying to do 3D printing with graphene materials. So let me explain you why graphene can revolutionize 3D printing. So in this case, we can make polymers which are enhanced with graphene materials. So in this case, polymers become electrically conductive. So it means that we can actually make electronics with this graphene filaments. Also, those materials conduct heat. So in this case, it helps us to make heat sink, so it prevents overheating of devices. It's so extremely important for many practical applications. And graphene also makes materials stronger, so we can create composite materials which are strong and light. And also, graphene is green material. So just let me briefly show you how materials look. So we make materials for FDM printing, so they look like wire, and this wire can be inserted inside of 3D printing, and later on we can use it to make some items. Let me just move forward. So before we move forward, let me just briefly show you how do we make electronics now. So we start with large silicon wafer. After that, we load it in a huge machine which can cost several $1 billion. And we do many lithographic steps. And as a result, we get something that what you can see on the screen. So all those little squares are silicon chips. After that, we cut it into small pieces and we package it. And as a result, we get something small like this microchip. And right now, we learned to make those chips at very low price. But if you think about it, let's assume you want to make large three-dimensional object with a lot of sensors, with a lot of different things attached to it. So in this case, we definitely need a lot of wires. So now I will show you briefly what we can do with graphene. So with graphene, we can do 3D printed wires, and we can actually embed those wires inside of plastic envelope. So let me just show you this simple example. So it's flexible object, and graphene wire is inside of this. So now let me see if it's right polarity. So now we can just power it up and light works. So now let me show you another example. So what we did here, that blue color represents not conductive plastic, and black color is actually our graphene electrodes. So apparently it's highly flexible material, and now I will try to do a small live demonstration and try to show you how it works as a touch sensor. So may I have it here? So let me see. Just 1 second. I'll try to hope it works. Fingers crossed. Okay, I think that's it. So, and again, to point out, it's definitely possible to do it with conductive inks. So you can definitely print electrodes on the top of the surface. It's kind of old technology. It has been around for many years. But for the first time, we were able to 3D print electronics. So now let us move on and try to think what we can do with this technology in the future. So what we can do right now, we can actually 3D print objects, but they're more like toys. But let us imagine we can print not only wires, but we can also print batteries. We can print light sources, sensors, and so on. In this case, in the future, we would be able to print objects which can walk, communicate, interact with us, move, and maybe even fly. And so ultimate goal of our company is to make a universal 3D printer which can combine many different materials in one print and actually make virtually everything you want. So let's assume that this universal 3D printer exists today. So what would you do with this material? And I tried to ask many people, many different people. So the most popular answer was, let us first make a couple of exactly the same printers, and then I'll think of something else. So what's next? So I have a lot of friends in academia, and they said it would be so great. So we have so many ideas, but sometimes it takes us weeks or maybe even months to get done what we want in machine shop. So in this case, we really would be able to test our ideas in days, and it would greatly accelerate education as well as research and development. And also, I have a lot of friends who are artists or creative people. And for them, such machine would bring ultimate freedom to express themselves. So if they can envision it, they can also turn it into physical object. And to finish my talk, I want to discuss how this printer can be used in space, because we know that our next talk is going to be about space elevator. And our next speaker will explain us that that's extremely difficult and very expensive if you want to bring an object from Earth to the space station or even further. So, and apparently, on a space mission, if something is broken, there is no Amazon, there is no McMaster. So, and there are 100 or maybe thousands of different parts which can get broken. So in this case, if we have just limited amount of, let's say, starting materials, and we can print what we need during as we need it, it would be incredible opportunity and would greatly help us with further space exploration. And I would be very happy if you share with us your ideas and what would you make with such 3D printer. And I'm very excited to be here, and I'm greatly thankful for the opportunity to present our work, and thank you very much for your attention.
Elena, does graphene exist in physical form enough that we could hold it? Or do you work with blocks of graphene?
Yes, actually,
chunks of it? Or?
I have two companies. So my first company, Graphene Labs, actually sells graphene, and we have about 7,000 customers. So we make graphene in the form of powder, so it looks like black powder. We also grow it by chemical vapor deposition, so it looks like it is grown on cup of oil, and then we transfer it on the top of the wafer. So it all exists, and we've been selling all these materials for almost 5 years.
I see. And is this the same material that's in a pencil? Graphite pencil?
It's not. There is no simple answer to this question, because material which is used in our pencil, it's called amorphous graphite. It's relatively poor quality and it's relatively cheap. Material that we start with, it's called flake graphite. It has much better quality. But in general, yes, it's very similar. It's similar material, and it's basically, if you imagine graphite, it's like stacks of graphene. And if you know how to split graphite crystals into isolated sheets, so you will get a graphene material, and it's something that we use to mix with polymer and further use it in 3D printing.
So last question, how long does it take to grow a useful amount of graphene?
If we use two different methods. One is chemical vapor deposition. In this case, we grow single-layer graphene on metal. And usually it takes a few hours. So we basically have to load material into CVD furnace. Then we turn it on, it heats up, and the process runs, and then it cools down So the longest part of the process is basically to wait for furnace to warm up and to cool down. And for 3D printing, we start with natural graphite, which is actually can be mined in Canada, in Quebec. So there are a lot of natural resources here. And after that, we do chemical splitting, and kind of take graphite into thinner and thinner sheets.
Does it sell by the pound?
Yes.
Or by the gram?
Actually,
or by the microgram?
Now materials are relatively inexpensive. So in this case, the price of materials we are working with is about between $100 to $400 per kilogram. And we only need, let's say, 5% of graphene to be added to plastic. So there is a price by no means is a bottleneck.
Okay.
So we are ready for commercial use.
That's good news for Brad Edwards, I'll say. All right. Thank you so much, Elena.
Oh, let's get a picture.
Right.